And the instruments, they are called it the brush, yes? The brush instrument. Virtual articulator, and you have this data taken from the program. Occlusal thickness 0.5, thickness in periphery 1 millimeter, and smoothen 3 millimeters. And you do the design of the splint. It's all in real life, so I mean 11 minutes for the splint. I think it's a good productivity. He didn't like that point, so he wants to raise it. It was too much lingual. See? So he can adjust thickness according to the position of the upper model. And that's very convenient, I think. The only thing I would change here, I would make the canine guidance design, but it's up to the doctor. Canine guidance design. So we'll do more steepness here in order not to be just it's stabilization splint. But I would do it also stabilization and protective splint. But there are so many designs of this splint that it's not that important. What is important is really that there couldn't be very sharp contacts. They have to be very smooth, because otherwise it will be for the patient on the splint too much interference. Because it can be like, deep holes and deep fissures, deep pits. It has to be with the freedom. We have to give patient the freedom to have side movements with the splint. So that's it. The splint is done. Because yesterday you asked about the splint, yes? And you send it for the print or whatever. So it's not your decision in what position the splint has to be, and that's what doctor can do for you. And plan is still.
You do your splints in the lower jaw, not in the upper.
I prefer lower jaw. I did on upper, I didn't like it. Patients are not so happy to wear it.
Yeah, but in the lower jaw you don't have the guidance, and
you can. In the design you can. The anterior guidance, yes, but for the splint, the anterior guidance could be also for the canine bumps that you make. It's okay for the splint, because the splint has to be in disocclusion between anterior teeth. So it doesn't matter, just it's more comfortable in the lower jaw, more aesthetic. And that is also another function that they don't talk a lot, but actually I like it very much. This is, for example, when you want to do a walks-up or it's a dentulous patient and so on, and you want to work with curves, like curve of Spear or even curve of Monson. So there is possibility here. It's not very often used, but it's very good. And for example, like in our case with Panayotis, we've seen that, for example, counterplane is not very good, but frontal plane for him is very good. So we can work on it. Is it working? Yes. For that we have to do several more cephalometric points. One of them is crista galli. It's inside the base of the skull. So this is occlusal plane, yes? Or actually it's not occlusal plane, this is prosthetic plane. And we can switch on other planes that we have. Like this is advanced cephalometric that we did today. You know how to do that. And for example, this is heat plane. I don't like hip plane, but there are people who like it. The point is not so easy to place on the bad CBCT, but it's possible. Look, it's hip plane, or it could be where is counter plane. We replace, because some think that hip plane is very nice reference for occlusion plane. Why not? Or we can choose which reference plane we want to repeat in our rehabilitation. Okay, he decided to use hip plane. Okay, fine with him. Then there is here a function showing in the models. It is here. Occlusal planes. We can place it according to the horizon. It's horizon here. Or we can use it manually. So this is like hexacut. You'll choose the level of the curve that you want to do. And you can adjust the position, like the curve, the width, and the length. So you decide what plane you want to repeat, so what plane you want to copy. So it will be horizontal, okay. Or it will be hip plane, all right. So if you set here hip plane, this curve will be automatically parallel to the hip plane. And you have just manually to adjust where you want it to be. Or you can, you see, you just do it as we did before. You can raise it, occlusion plane, you can put it lower. Like, you know, imagine an articulator, you have to decide where to start the walks up. You start sometimes with occlusion plane, like in Slavish concept. Or like in Broderick. You know, remember the occlusion plane finder in Broderick? No. 19th century, was very nice too. So you decide that the occlusion plane will be on certain level. Just don't look at these teeth, because it's for the rehabilitation when the teeth are destroyed, when there are no teeth, for example. For example, you want to see where, for example, will be division between upper and lower teeth, and what kind of curve sphere or occlusion plane you would see. Here is Christogalli, it's inside the brain. So he places this point, Christogalli, and the program will do the diameter of a curve sphere. That's this diameter is to go through Christogalli. So Christogalli, find this point, place this point, and right now we want to visualize the Monson curve. Make the circumference 6 Christogalli joints. So this is our Monson curve.